Here we go. We got areas of circles and sectors. Well, a sector is like part of a circle, like some area of a circle. And we're going to look at that in a second. So before we can do anything, we have to refresh on our formula for an area of a circle. Well, if you remember back a couple of years, it is what? Pi times radius squared. Pi times radius squared. So you need the radius of your circle in order to solve for the area. And when you type it into a calculator, just type it in all at once. Pi times whatever squared. Okay? Just so you don't mess around with your order of operations, right? So just type it all in at once. Well, when we're dealing with this sector now, let's take a look at my circle over here. Okay, I broke off a sector, so I'm going to fill this in with green. We'll shade this area. So really, what we want to do is find this shaded area, this sector right here. Okay, and we're going to say the area of this sector, we'll just call capital A, area of that sector. Well, to solve for that, if I think about it, that little sector's area is a small part of the entire circle's area. So I can write that as a ratio. So A, which stands for just that sector's area, that green stuff, over the entire area of the circle, which is pi r squared. And I could set that equal to anything else that relates with that part compared to the whole circle. Whether it's an angle measure or an arc length in the circumference. Well, in this case, if you see I have x degrees written here for its angle measure of that sector. So I could set it up. If you think about it, this A was the area of that sector. Well, x is the angle measure of that sector. This pi r squared is the area of the whole circle. So how many degrees is the whole circle? Well, 360. So there's a proportion I can use, right? Those ratios match up. So think about it. I have the sector on top, things that deal with the sector on top, and things that deal with the entire circle on bottom. Right? So the area of the sector over the area of the whole circle equals the angle of the sector over the angle of the whole circle. Right? You just have to have things that match up in order to set up that proportion. And let's take a look at how that works here in a problem. It says find the area of each shaded sector. Well, I just have one problem, so I should have just said duh. Round to the nearest tenth if necessary. Well, let's take a look. So I'm going to find this blue stuff right here. Okay, so I'm going to call that A. Call this guy capital A here for the area of that sector. So A over the entire circle's area, which is pi r squared. Well, do I know the radius? Yes, it is 8. So I'm going to change that to 8 squared. And most of you could probably say, well, 8 squared is 64. So let's go ahead and do that and change it to 64 pi. So 64 pi, or pi times 64. I like to have the number first. Okay? And we set that equal to, well, the angle measure of the circle, which is, or not this angle measure of the sector, which is 72, over the angle measure of the entire circle, 360. So remember, they just have to match up. Right? I got everything that deals with the sector on top and everything that deals with the entire circle on bottom. And now it's just our cross product. So I take 64 times 72, 64 pi times 72, which in this case I get about 14,476.458, so about 4.6. And you can just leave whatever number you get on the calculator and divide it by 360 because we take 360 times A, and to solve for A, we divide by 360. And in this case, we get about 40.2, and it's an area, so the area of that blue shaded region would be 40.2 centimeters squared. Always have your unit squared for area. Okay, so just set up a proportion, right? The sector on top, the circle stuff on bottom, area on the one side, angle measures on the other side, and it should work out. Okay, you might get other types of problems that deal with areas and not just dealing with sectors. For example, it says, find the radius of a circle with an area of 58 square inches. Well, area, circle, area formula. That's what I'm thinking of right away. So I'm just going to go ahead and write that down. Area equals pi r squared. And let's fill in information we know. We got 58 for the area. Right, got that right here. Equals pi times radius squared. And we're trying to solve for r, solve for the radius. So we have to get the r squared by itself. So we divide by pi. Divide by pi. And I could round this decimal, but even before that, I'm just going to write this here. 58 pi equals r squared. So instead of rounding a decimal, let's round at the very end. So to get r by itself, we take the square root. So I take the square root. So those cancel. So r equals, now I can type in the square root of 58 divided by pi. So square root of 58 divided by pi. Don't forget to end your parentheses if you're putting this in a calculator here. And we get about 4.29, so about 4.3 inches, right? It's just a distance, it's just a radius, so 4.3 inches. And if I was trying to find the diameter, I would do the exact same thing, and I would double it, right? So if I really wanted to find the diameter, do the exact same process and just double it, because the diameter is twice the radius. And that's all there is to it. So remember, just don't round until the very end. Let's get used to that. And another example here. It says a pi has a diameter of 9 inches. I might give it a little drawing here. So a pi diameter, 9 inches. And it's cut into 10 slices. 10 slices. Boy, I might botch this up. See if I can cut this into 10 slices. So 1. Boy, here we go. 2. There's a couple. Let's put another line. Put another line. And one more. How many I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they're close to congruent. That wasn't too bad. Okay. And I want to find the area of one slice to the nearest hundredth. All right, so we got to have a game plan here. Well, what are some things I could find? Well, I could find the area of the whole circle. Right? I could use pi r squared to find the area of the whole circle. And then what? Divide that by 10, right? Because I got 10 slices. That would fine for one slice. So there we go. Come up with a plan and then go ahead and attack it. Well, we're going to take pi times radius squared. Well, the diameter is 9, so that must mean the radius is half of that, so 4.5. So we're using 4.5 squared over 10. So the trickiest part is be careful when you type this in the calculator. I could do the top first and find an answer and then divide it by 10. Or if I'm going to type this in all at once, maybe put that in parentheses for your numerator, just to be careful. So I'm going to go pi, I'm going to put my left parenthesis, pi times 4.5 squared, and my parenthesis, divided by 10, and I get 6.4, or 6.36, oh, it says right on the nearest hundredth, my fault, 6.361, so I leave it as 6.36, and we got what? Area, so we have inches squared for one of the slices. So find the entire area and divide it by 10. So I typed it in all at once. You could find the area first and then divide by 10. Either way. Okay, so a lot of different ways that we're going to apply the area, or possibly areas of sectors. We're just kind of using that proportional thought we had right away and your area formula. And that's all we got.